Okay, here is January 2015, and these are questions 14 to 19. So 14 says, Corinne is planning a beach vacation in July and is analyzing the daily high temperatures for her potential destination. She would like to choose a destination with a high median temperature and a small interquartile range. She constructed box plots shown in the diagram below, which destination has a median temperature above 80 degrees and the smallest interquartile range. So what you first need to know is that your median temperature is going to be talking about the line that is in the middle of the box. That's your median, that's your Q2. Your interquartile range is the distance between Q1 and Q3, because interquartile range will always equal Q3 minus Q1. So obviously the smaller the box, the smaller the interquartile range. So now, if we look at our options, Ocean Beach does not have a median temperature that is above 80. Whispering Palms does, that could work. Number 3, Serene Shores does not go above 80 for the median temperature. Pelican Beach does, so it's between choice 2 or choice 4. Now if we look at the size of the box, Pelican Beach is significantly smaller, and that has a smaller interquartile range, so our answer would be 4. Number 15. Some banks charge a fee on savings accounts that are left inactive for an extended period of time. The equation y equals 5,000 times 0.98 to the x power represents the value y of one account that was left inactive for a period of x amount of years. What is the y-intercept of this equation, and what does it represent? Well, if you remember, the equation for an exponential function is y equals a times b to the x power, where a will always represent the y-intercept, and your b value is your growth value. So it could be a growth value that is either increasing or decreasing, depending on if b is greater than or less than 1. So it says, what is the y-intercept of this equation, and what does it represent? Well, from this equation, we know that 5,000 has to be the y-intercept, so it can't be choice 1 or 2. And it's going to represent the amount of money that is in the account initially. Okay, so at 5,000, okay, so if you saw the graph of this, it would start at 5,000 on the y-axis, and because it's less than 1, it's actually going to decrease exponentially. But this is where it's starting at. So when x is 0, the amount of years, so meaning no time has passed, you're going to have 5,000 in the account. So choice 3 would be your answer. Number 16. The equation for the volume of a cylinder is V equals pi r squared h. The positive value of r in terms of h and v is, so we always seem to see one of these questions, at least one per test. So we really need to know how to manipulate the equation to get one letter alone, in this case r. So what you need to look at is the letters that are attached to r, or even the numbers. So pi and h right now are attached to r, and they're attached by multiplication. So the opposite of multiplying would be to divide both sides by pi h. So you're left with v over pi h equals r squared. So the opposite of squaring is to take the square root. When you take the square root and the square will cancel each other out, so you're just left with the r, in this case, equals the square root of v over pi h. So your answer is choice 1. Number 17, which equation has the same solutions as x squared plus 6x minus 7 equals 0? So if you look at our answers, these are all in the form of completing the square. So the first step in completing the square is to isolate your x's. To do that, you need to add 7 to both sides of the equation. So you're left with x squared plus 6x equals 7. Okay, the next step is to find your b over 2, and and your b over 2 squared. So b in this case is 6. It's the number that's always in front of just the x, so that's 6. B over 2 is 6 divided by 2, which is 3. And b over 2 squared is 3 squared, which is 9 in this case. So what we're going to do is we always add our b over 2 squared to both sides of the equation. So we're going to add 9 to both sides. And we're left with x squared plus 6x plus 9 equals 16. So automatically we can eliminate choices 1 and 2 because we need it to equal 16. So the next step in completing the square is you're going to have x and then you're going to add it to your b over 2. In this case, b over 2 is 3, and it's a positive 3, so it's going to stay positive. X plus 3, the whole thing squared, equals 16. So it has to be choice 4. Number 18, two functions, y equals the absolute value of x minus 3 and 3x plus 3y equals 27, are graphed on the same set of axes. Which statement is true about the solution to the system of equations? So the first equation is nice. It already has y alone. You just have to remember how to find the absolute value on your calculator. And that can be found by hitting the math key and scrolling over to num, standing for number, and it's choice 1, which says abs, which stands for absolute value. Okay, 3x plus 3y equals 27 is the second equation. However, y is not alone, so you need to get y alone. So the first thing you're going to do is subtract 3x from both sides. And when you do that, you'll end up with 3y equals negative 3x plus 27. Then you're going to want to divide every term by 3 to get y completely alone. So you'll have y equals a negative x plus 9. So here's the other equation that you're going to type into your calculator. Okay, so when you type both of these in, you can either look at the graph or you can look at the table. I suggest doing both. I think sometimes in this case the table is easier to read. So I'm going to write x and then I'm going to have y1 and y2. So let's say that you typed this equation in first, and we'll call that y1. And you typed this equation in second, so we'll call that y2. Okay, so what I need to look at the table is, let's see, they say 3, 0, we're talking about 9, 0, 6, 3. So my x values that I'm looking at are 3, 6, and 9. So y1, which again is this equation, when I type that in, when x is 3, y is 0. When x is 6, y is 3. And when x is 9, y is 6. And my y2 over here, when I type that into my calculator, when x is 3, my y value is 6. When x is 6, my y is 3. And when x is 9, my y is 0. Okay, so is 3, 0 the solution to the system because it satisfies the equation y equals the absolute value of x minus 3? Well, it's not the solution to the system. In order to be the solution, it has to be a point where both graphs are going to intersect. So, based on my table, or if you look at your graph, based on your graph, the two graphs intersect at the point 6, 3. So, it's not choice 1. Choice 2 says 9, 0 is the solution to the system because it satisfies the equation 3x plus 3y equals 27. Well, yes, 9, 0 is on that line, but it is not the solution to the system because it doesn't satisfy both equations. Choice 3 says 6, 3 is the solution to the system because it satisfies both equations, and that is true. Your answer is choice 3. So if we look at choice 4 just to see, it says 3, 0, 9, 0, and 6, 3 are the solutions to the system of equations because they all satisfy at least one of the equations. Again, that's not true. It has to satisfy both equations in order to be a solution. Number 19. Miriam and Jessica are growing bacteria in a laboratory. Miriam uses the growth function f of t equals n to the power of 2t, while Jessica uses the function g of t equals n to the power of 4t, where n represents the initial number of bacteria and t is the time in hours. Okay, so if Miriam starts with 16 bacteria, how many bacteria should Jessica start with to achieve the same growth over time? All right, so f of t equals, remember Miriam is 16, starting with 16, that's her n value, to the power of 2t. So this is Miriam. And Jessica is g of t equals some number n, we don't know yet, to the power of 4t. So if you were to type these into your calculator, 16 to the power of 2t, remember whenever you see f of t, f of x, anything like that, it's just standing for the letter y. So if you wanted to type this in, you would say y equals 16 to the power of 2. Instead of t, you're going to replace it with x on your calculator. Okay. So what you could do, here's one option. There's a couple different ways you could find this out. What you could do is type in Miriam's equation first. So you have your x and your y. We'll call this y1 for Miriam. And if you look at just the first couple, okay, when x is 0, your y value is 1. And when x is 1, your y value is 256. We'll just look up to 2 because the numbers get pretty big. When x is 2, your y value is 65,536. So what you could do is to figure out where these two equations are the same is you could just do a guess and check. So we don't know what n is. N could either be 32, n could be 16, n could be 8, or n could be 4. So if I type in 32 to the power of 4t, but remember I'm going to use x in my calculator, and I look at the table, does it match up? Well, no, it does not. Okay, and I could go through each of those and see which table values match up exactly the same for not just the first, but for all of my table values. Okay? Or what you could say is, okay, well, 16 to the second power is 256. So our next equation is n to the fourth power, if you want to think of it like that. So which of these values to the fourth power also gives us 256? Well, the only one that would work is 4 to the fourth power. It gives us 256. So our answer is choice 4. And if you wanted to use your calculator with the guess and check method, okay, so what you're going to type in is 4 to the power of 4t. Remember, instead of t, you're going to write an x. When you look at your table, all of the y values will be the same. 1, 256, and 65,536.